So testing is one of those subjects that I often hear very opposing opinions on how tests should be written and what type of tests should be written. I've heard arguments that unit tests are kind of a waste of time. It's just kind of busy work and it makes your code a little bit more brittle to refactor. And I've heard opinions that unit tests are really great and they really help you shape what you're trying to develop using like test-driven development. And they're really good at catching errors. So based on those two opposing opinions, I want to kind of give my thoughts on it because I've been doing testing for about 10 years now on my software projects. Every project I've been on, it's been a project requirement that stuff has to be tested, right? How you write the test is kind of dependent on the developers and the features that you're adding, but stuff needs to be tested, right? I work on government contracts, and I'll say there's a higher bar of quality that's expected when you win these contracts and you're trying to build systems out for your clients. So let's talk about the two different approaches. The first approach that you might have seen is the testing pyramid. So this is basically saying that, hey, and I know my head's kind of missing some of this, but when you write systems, you should be writing a ton of unit tests. This is like the base of the pyramid, the core of what you're testing, followed by a little bit less integration tests. And then finally, you have end-to-end tests. Now, I would say that the terminology for end-to-end and unit tests and integration tests, they're very fuzzy. I don't think people can even decide like what is an actual unit test. Some people say it's testing a function, like a black box test of a function. Some people say it's testing out a class, like a Java class or something. You really have to decide what is your unit. Sometimes these terms kind of bleed into each other, but the overall concept is that the higher you go up in this pyramid, the more effort it takes developers to write these tests, and also the more costly they are to maintain. So imagine if you have a huge microservice system and you have to deploy 13 different microservices that are all integrated together. To do an end-to-end test, that would require a lot of resources, a lot of expertise to make sure those are all hosted up. And then you have to kind of run through end-to-end tests over your UI and make sure everything works as expected. And they're slow, right? That takes a lot of time to spin all that stuff up, click through a UI. So I think there's some merit to this testing triangle, and that's kind of the approach that I've taken on a majority of my projects. We do a huge amount of unit testing, and then we try to leverage hard on integration testing. And then finally, we do some form of end-to-end testing. Now, there's another concept called the testing trophy, which basically says, don't do as many unit tests. Try to put all your effort inside of integration tests. And then at the very top of the pyramid, again, you have like end-to-end testing. And then at the very bottom, there's like a static section, which basically likes to argue that your TypeScript static check analysis will like catch errors, which it will. But honestly, I don't put as much emphasis in your static type checker to actually like catch errors. I do agree with both sides of these. I think they both have good merits. And I want to kind of talk about the issues with unit testing, integration testing, and end-to-end testing. And hopefully it helps you form your opinion or just give you some type of perspective about where I'm coming from. Let's talk about the first thing, which is unit testing. Okay, so a unit, you have to define what a unit is, right? So in many cases, what I define a unit is a single function, okay? Now, hopefully, if you have a single function, you can do some type of black box test. So you have a black box here. You have no idea what's inside of it. All you know is that it takes in some inputs. Okay, so I'll just go ahead and say like inputs here. And then over here, let's just go ahead and say outputs. Now, the whole idea of black box testing is that you don't know how this thing works under the hood, and you shouldn't have to know. All you know is that if you pass it some arguments, if this is like a function, you pass it some arguments, you should expect the return type to be a certain value. So I'd say unit tests work really great when you have a really simple black box function, which, for example, you could do a filter function. You could do some type of like date conversion function where you pass it in some date and it formats it into something else. So formatters, filters, some type of sort function. So basically it's like a really small function or algorithm. For example, let's say you wanted to write a path finding algorithm, right? That's something that takes in some inputs and you can verify that outputs work the way they do. Now, sometimes your black box, if you're using like AI or something that's non-deterministic, your outputs, you don't just check certain values, you have to check ranges, right? You have to verify that what is the quality of the output? Is it close enough? But we won't really get into that. For most of the things that I built with software and web development, this is like utility functions that you might see in your front end or your back end or something like that. Maybe you have like business entities where you have to construct an entity and you have a bunch of different validation rules that happen when you call methods on that. This is a great example of when unit testing is awesome. Now, the issue that I start to have with unit testing is when you have a unit which has to interact with various third-party services such as AWS S3, AWS Dynamo, maybe a database, you're talking to Postgres. Maybe you have to write to a file system. So when this black box, starts writing things to an S3 bucket, or let's say you have like a Postgres database. And so now it's not a very clear, like, okay, we give it inputs and it gives out outputs. Now it's an actual function that does things. And you don't really know how it's going to call those things or what it's going to pass to those things. So for example, we have a function called doStuff. Okay. So unfortunately, you can't just run this function because it's going to try to actually write to S3 and it's going to actually try to write to a database. One argument is that if you're connecting with third-party services like a database or a file storage system, you are doing an integration test. So in order to unit test the actual logic, so for example, inside of here, let's say you have like if statements, you have like branch logic or something like that. If you wanted to verify, maybe you have a requirement to have code coverage or something, that certain branches are taken, how do you verify that? Well, you have to end up doing something called either stubs or mocks, where instead of this thing writing to a real S3 bucket, you basically stub out the function calls and have it do nothing and return some type of canned response, so that when you pass in the inputs to this function, it's going to go ahead and run your function, but it's not going to try to write to a database. It's not going to try to do a third-party API request, right? And that allows you to quickly just verify branching logic and make sure that the business logic that's inside of this function does what it's supposed to do. So instead of this function directly importing these, AWS SDK libraries, or instead of importing a Postgres driver, what people recommend doing is that your function itself, you can do inversion of control, and you can inject these dependencies in, which make them a lot easier to test, right? So instead of the doStuff function just taking in inputs, you could also potentially pass in a context, which could have like a function here called write file. And then you can also have write to DB. Does that make sense? So in your test, let's say you're using Jest or Vitest, what you can do instead is that when you call the function, you can pass in a stub function here and have it do absolutely nothing. Right? You just want this thing to be able to run and not throw exceptions. This is great. Now you can actually test the logic that was inside of this function without having to write to a real database. So another good reason to do this is now you can actually, inside these stubs, you can force it to basically throw exceptions, right? When you're interacting with real dependencies like S3, sometimes S3 is going to throw errors. Sometimes there might be an error when you do that S3 right, and now you have the ability inside of a unit test, you can stub that out. So now you can say, hey, when this doStuff function makes a call to write file, instead of it just returning void, I want you to actually throw an error so that I can verify in a test that stuff was handled gracefully when these downstream services were to throw exceptions. So in order to make this work well, one thing I would highly recommend is that when you look at a function, you should know exactly what it needs in order to work, right? If you look at the function signature, you should know what dependencies it needs. Otherwise, you're going to run into some really hard maintainable problems when writing tests. So for example, if you were to write this function like this, doStuff, and inside of it, it just happens to make a call to S3, or it happens to make a call to Postgres, or maybe it actually calls another function, and that other function makes another call to another function. And somewhere inside that third function, it makes a call to, we are just going to go ahead and say it makes a call to Elasticsearch. So the issue is that you're trying to unit test this, but this thing is going to call another thing, which tries to call another thing. And now this thing fails because you didn't supply the proper dependency, via a mock or a stub. And now it makes testing a lot harder. So that leads me to another topic of, should you write sociable tests or should you try to mock out everything? Should you try to stub out everything? If you look at these three boxes, this is all the code that you own. This is the code in your system. These things are dependencies of like third-party systems or third-party libraries, right? So the question is should you mock out this right here if you're trying to just test doStuff? My opinion is that you should write sociable tests so that you can actually verify that your different pieces kind of work together properly. Some other people might say that you do want to mock this out. I would say that the more stuff you're mocking out, the more hard it is to maintain this code, and it's a lot harder to refactor this code. So if you just do the sociable test, let this thing go all the way through, let it call Lodash, let it call whatever third-party library you brought in, let it call a date library like Luxon or DateFNS or whatever it's called, and find a way to structure your code so that you know what dependencies are going to be needed. Which leads me to another point of some things you should probably avoid when setting up your code I would say try to avoid containers, like I think one's called like a service registry, where you have this like global thing that you import into your different files. And then you kind of like set that registry up with your mocks. And then when this code runs, it'll pull in those mocks and start using them. I think this makes for very hard and unmaintainable code, because when you're testing a function, you don't know what the sub functions that it might be calling actually need. So I would avoid a service registry. I think an IOC container might be very similar, where there's like this global thing that holds like all your dependencies, and then you're basically passing that container to all these, and it can have access to whatever it wants to write to the system. I think it's a much more clear if you put right out the bat, like this needs a write file function, and then it also needs a write to DB function, and then it also needs a write to Elasticsearch function. And then finally it takes it as normal inputs, right? Because then off the bat, when you're unit testing this function, you know these are the things it's going to need, and you can just pass in those mocks or stubs. So going back to the main arguments, I've heard people say that unit testing is kind of a waste of time, and it kind of prevents you from moving fast because refactoring this code becomes even harder, right? You can't just make some changes, because now when you make changes, you have to go and like look at what are the dependencies and like make sure you have that all set up properly, which I don't know if I truly agree on. I think if you structure your code properly, it's not too hard to just pass in stubs or mocks and like verify what needs to happen. Now, for the people who follow the testing trophy, I think a lot of them probably say that unit tests aren't as useful as integration testing, which I would say on my system at work, integration testing has been the one thing that has helped us stay confident when we push code, because we know when an integration test passes that more than likely the code's good. When a unit test passes, there's still a chance that like the unit test was written poorly, or the unit test isn't actually like verifying what's supposed to be verified. Sorry, there's like so many different topics I could probably talk about when it comes to unit testing. The last thing I want to touch on is that in order to have a successful unit test suite, you need to make sure you're doing your unit tests correct. Okay, and one way to know if your unit tests are kind of written properly is that if you were to go and refactor all of the code that's inside of this, or refactor code that's in here or in here, if every single one of your tests fail in your unit test for like a really trivial change, like let's say you decide you want to switch the order between writing to S3 first or writing to Postgres first. If your tests start failing because you changed the order of what you're writing to the buckets, I would say that you've written a pretty poor test. You want these tests to be resilient so that it gives you more freedom and flexibility to refactor as needed. That was the whole point of testing, is that it gives you confidence when you're refactoring. And if you don't have confidence when you refactor code because now your entire test suite starts failing, then you probably need to reinspect how you're writing tests and try to make them less brittle. All right, so let's move on to the second topic, which is integration tests. So if I go back to that same diagram, let's look at how we could test this potentially by using an integration test. So instead of mocking this stuff out, what you actually want to do is you'd have some type of either real or locally running Postgres database or a locally running S3 service, and then you'd actually call this function. And then down here, you probably actually want to have a real running OpenSearch cluster. Okay, so it's still like the same system that that's under test, but now we're not mocking stuff out. Now we're actually writing to some type of real service, which means that stuff is going to take longer. You have to write stuff over the wire. You have to wait for that service to kind of churn and write the data to disk. And then you have to wait for that to send back a response. So you're kind of adding some extra time to your tests. But the great thing about this is that now you've actually tested all these things fully connected together, right? And so if I were to write a test and then I come in through here and I were to refactor C a little bit, when I run the test again, if this test fails, I know with pretty strong confidence that like I really messed something up, because now all this stuff is like tested together, and that's really good because you want to actually verify that stuff works when it's connected. There's so many different times where you'll write a unit test, it looks great, everything is green, everything passes, and then you start hooking that unit that you used to something else, and then the system just doesn't work. The UI just breaks or something. So just because the unit passes your little unit test doesn't mean that it's going to work perfectly when you start integrating with other pieces of your system. So I would definitely, I'm kind of leaning towards like, I do agree that integration tests kind of give you the biggest bang for your buck. The more you kind of interact with real things in your system, the more confident your test is going to give you that you're doing the right stuff. It just takes a little bit more time to write and a little bit more time to spin this stuff up, because obviously having all these things running takes a lot more resources. To kind of give you an example, at work, we have a CI/CD pipeline. We have a Docker file that basically spins up this OpenSearch local instance. It spins up a DynamoDB local instance, and it spins up a S3 local instance. And there's other services we integrate with too, right? For example, this one might talk to AWS SES for sending out emails. Okay, but we don't want to have an integration test really send out emails. So sometimes we do mock out like certain services, right? SES, yeah, we'll probably mock that out. SQS, do we really want to mess with like an event queue for this file? Probably not. So we'll mock that as well. And we'll have like a flag. So when we run this in CI/CD, we'll say this is a testing run. And when this code runs, it just kind of mocks this out and just kind of either calls the function directly if this is like an SQS event, or it just doesn't send out an email or just maybe log something out so we know. But again, you're just testing a small little thing together with like a database. For example, this could be like an API endpoint. So I'll just say like API endpoint. And basically you're just verifying with like an HTTP request. Go ahead and say like HTTP request. You're just verifying that when you call this request, that it does this stuff properly and sends you back the response. Now, even this can be written in such a way that's pretty brittle. I would say still try to treat this as a black box API instead of like writing your test to make the request, and then you go and you start inspecting your S3 bucket, or you start inspecting OpenSearch, or you start inspecting your database. I would say that that's kind of crossing a line and like diving into implementation details of your system. Again, try to approach testing as a black box approach. And if you need to, what you could do is you can actually have like a second API endpoint, which typically we do. Like, usually we have like a write some data endpoint, and then we have like a get some data endpoint. And this get some data endpoint could potentially, I don't know, return you the file, or maybe it returns you some data from Postgres. So your test would, step one, call post endpoint. Okay. And then step two, it would basically verify everything worked via get endpoint. That's how I would potentially write integration tests. Again, try to keep it as black box as possible so that your tests only know about your API endpoints. They don't know about the underlying things your system is using. I think that'll make for a much more maintainable testing suite. All right, last thing, I've been kind of talking for a while. My voice is going. Let's talk about end-to-end testing. This is the top of the pyramid. So these are the things, at least so they say, take the longest time to write and are the most expensive to maintain end-to-end. So the terminology for end-to-end testing, I think it's debatable. A lot of people say end-to-end means that you have an entirely fully functional running system and you test it end-to-end, right? So for example, if you're dealing with what I'm showing right here, where you have a lot of AWS services, you would basically make a PR to deploy all your code changes to a live environment. You wait for that stuff to get deployed, and then you have to go and actually run tests over that deployed environment and verify everything works as needed. I personally think that that is a way to make really brittle tests, and I honestly would call those more of smoke tests. I think that level of testing where you have a fully functional UI and an API and all your services are hooked together, I would say that that is more of like you want to write smoke tests just to verify that everything seems like it's working. In my opinion, what an end-to-end test is you have basically as many of these services as you can hooked together and running, but then you also have a browser. So if I say like browser here. So what you're going to do is your test is basically going to use Cypress or Playwright to pretend like it's clicking through your UI. And that is going to make your API calls. And those API calls are going to write to your various database services or file storage services. And you're going to use the UI like you pretty much would as a user. But I wouldn't say you need to have this fully deployed to a real environment. I would have this, everything should be able to run from a Docker Compose file, so that you can have certainty when people make a PR to your main branch, that when the PR runs all of these end-to-end tests with Cypress, you have a lot of confidence that nothing is broken because it actually went through your UI, went to your various pages, it clicked on buttons, it verified that data showed up in tables after you kind of created them in a modal, etc. So this is what I consider end-to-end testing, which basically is just you have a UI, you have a backend, you have all your services. Sometimes it could be local mock services running. But you want to kind of make sure that you're testing at the highest black box level possible, which is a user clicking through your UI. Okay. Now you could argue that this is still just an integration test because you're not really deployed anywhere. You're not deployed on your real environment. Now, again, there's like debate about nomenclature. Maybe I said something wrong. Maybe this is more of like a systems test, or maybe the smoke test I mentioned before where you're testing on a real deployed environment. Maybe that's a systems test. All I know is that this type of test, I think, gives you the most bang for your buck because A, it really allows you to refactor any parts of your system and not have to worry about going back and changing a bunch of tests, all right? If you have a UI, you click a button and it needs to create something in the database, that's all your test has to do is log in as a user, click a button, go to a new page, verify a record shows up. And behind the scenes, it gives you tons of flexibility to refactor whatever you want. Now, my final remarks about end-to-end testing is, again, this should be a black box. So if you have your Cypress tests or your Playwright tests and you're doing like spies on API requests, or you're doing some type of like mock services where you kind of mock out these different APIs, I would say that now your test is dependent on implementation details, and it's going to be a lot harder to refactor stuff down the road if you decide to change an API endpoint, or if you decide to change out, I don't know, how certain things are returned back from the API. I don't think you should be stubbing those things out. You should just let the user click through your UI and verify things at the UI level. Now, I say like for most applications and products, this is what you're going to be using. You have a UI, you have a backend, you have some databases, and you kind of verify they all work together. But I think as you get into bigger and bigger projects, the backend is a lot more complex. You might be using microservices, and those microservices might be depending on other microservices. And so at some point, it becomes very, very hard to like spin all this stuff up just to verify that you can kind of click through the UI. And so at that point, you have to kind of weigh out, like, what do I want to actually stub out? Where are the lines I want to draw where, okay, we're going to use some type of mock service here. Maybe that team has provided you a local Docker container you can run to kind of pretend like it's running locally. Maybe this team also provides something. But at some point, you have to kind of like weigh out what is the best way to test this system all connected together? Or can you just like draw a line and say, you know what, I'm going to make sure that my service does exactly what it's supposed to do, so that when other people can just trust that my service is going to work when they connect to it. Honestly, at this point, I'm just trying to keep on rambling so that maybe you'll learn one or two new things about testing. Hopefully you like this, but leave a comment if there's anything you feel like I should elaborate on, or if I missed out, or if there's something that you think I just said completely wrong, or if your team does something a little bit different from how I explained. I'm always open to hearing some feedback and how other people do stuff. Yeah, other than that, have a good day. Happy coding.